All right, welcome back, everyone. This is section 8.2, special right triangles, and we're going to see here that certain right triangles have properties that allow them to use the shortcuts to determine the side lengths without actually using the Pythagorean theorem. So in this section, you're going to take your first step into a larger world, as Obi-Wan once said to Luke on the Millennium Falcon in episode 4. And trigonometry, calculus, going to use these shortcuts like crazy. And your trigonometry teachers are actually going to they're going to expect you to know these and to, it's a memorization thing at first, but then you'll start to understand it as we go. So the first one is a 45, 45, 90, named so because of the angles, the acute angles of the right triangle. And it's also an isosceles right triangle, as you can see. You have S, you have S. And the theorem tells us that the hypotenuse is actually the square root of 2 times the length of each leg. So if each side is S, then the hypotenuse is S roots of 2. So now, I kind of deviate from the book when I deliver this lesson, so you obviously have the examples in the book that you can refer to, but I'm going to go with these couple scenarios to try to help condense this information and make it easier for you to understand. So the first scenario that we have in the 45, 45, 90 is when you're given a 45 side. So now here's what I mean by that. So let's put the 45s in and the 9. Really, we only have to put one 45 in. Sometimes it'll be looped like that. That'll denote a 45, 45, 90. Maybe they'll put the slashes on the sides, something like that. So any of those ways can tell you that you have a 45, 45, 90 special right triangle. And when I say given the 45 side, that's a side that is across from the 45 degree angle. So here's a 45 degree angle. So if we look across from that, let's just say this is 3. And like I said, the other leg could also be given. But that's all you're given. All right, there's a shortcut so that you don't have to work through the Pythagorean theorem in this case, because you could still do this one with the Pythagorean theorem, but it's way easier if you just use theorem 8.5. Obviously then, if this is the one we're given, you would know that the other leg is congruent to it, so that's 3. And the hypotenuse is simply whatever number you were given for the leg times the square root of 2. So that's it. It's that fast. Now, it comes from the Pythagorean theorem, of course. We would just go 3 squared plus 3 squared equals c squared. So that's 9 plus 9 equals c squared. So that's 18 equals c squared. And then when you square root both sides, you would break it down, and you would have root 9 root 2, which is just 3 roots of 2. So a lot easier to do it our shortcut way, but it's essentially, it's the Pythagorean theorem in a shortcut fashion. Now that second scenario is when you're given the 90 side, which is obviously just the hypotenuse. Don't believe the height. In this case, believe the height. So again, that's all you would need to know for it to be a 45, 45, 90. So now let's give the 90 side. Let's say it's 8, whatever. So now we can go backwards. And again, you could use Pythagorean theorem, but there's a shortcut. Instead of multiplying by the square root of 2, you're going to divide by the square root of 2. So it looks a little something like this. 8 divided by the square root of 2. Now, square root of 2 is an irrational number. You don't want to divide by irrational numbers. Your algebra teachers taught you this. So you want to rationalize this denominator. And to do that, you multiply by 1 in disguise. So you have 8 roots of 2 over root 4, which is just 2. And then, of course, you can simplify that to 4 roots of 2. So each leg is going to be 4 roots of 2. So this seems like a lot. You say this is a shortcut, but once you get the hang of it, you'll notice that, especially if it's an even number, you can just divide that number by 2 and then stick it in front of the square root of 2. And then, whoop, there it is. So those are the first 2 shortcuts. So moving along. Now, the 45, 45, 90s, they really could have been done with Pythagorean theorem. This next shortcut is all on its own, the 30, 60, 90. Watch how cool this is. So when you have a 30, 60, 90, which again means that one of your acute angles is 30 and the other one is 60 in a right triangle, And I'll prove this to you in class of why this actually works. And the shortcut tells us that the hypotenuse is twice as big as the shortest leg. So my hypotenuse is the longest side, of course, across from the right angle. And it will always be double. So if you have a 2s going on right here, then the side opposite 30 will be s. And then the longer leg, the side opposite 60, is just s roots of 3. So whatever number you have as the side opposite 30, just multiply it by the square root of 3, and there's your longer leg. So now let's see what it looks like. 3 different scenarios here. So let's label our right triangle. So I have my right angle, put my 30 here, which leaves my 60 there. All right, and let's give them the 30 side. So again, the 30 side is going to be the side that is opposite the 30-degree angle. So if we're given this, let's just say it's whatever, just making some things up here. So if it's a 4, so watch how quick this is. You're stuck, right? You can't use Pythagorean Theorem. You only know one side. You don't know A, you don't know B, you don't know C. But if it's a 30, 60, 90, that's all you need is one of the sides. The relationships tell us the hypotenuse is just double it times 2. So it's 4 to 8. So the 8, so in a 30, 60, 90, if the smallest leg is 4, the hypotenuse is always 8. And then the side opposite 60, I just go 4 times the square root of 3. And that's it. That's all you got to do. So how nice is that? Let's check out the 90 side. AKA, again, the hypotenuse. Believe the height. Let's put our 30 in. Put our 60 in. So say my hypotenuse is 10. Well, real quick, I know the relationship that exists. That means the smaller side, the smallest leg, is 5. And then once you have that, you can go 5 roots of 3. All right. Now the tricky one is the next one when you're given the 60 side, the side opposite 60. So say that is 12. And so we're going to have to rationalize this. When we go backwards now, to go to the smallest leg, we have to divide by the square root of 3. So it becomes 12 divided by square root of 3. And again, you have to rationalize that. So that's 12 roots of 3 over 3, which is 4 roots of 3. And then if the smallest leg is 4 roots of 3, the hypotenuse is 8 roots of 3. Just double it. So your scenarios right here, that's all you need to do. All right, and now moving along, let's just do a couple examples. All right, so find the missing side lengths in simplest radical. Here's a 45 side given. So we know it's a 45, 45, 90. Well, the other leg has to be 2 roots of 2. It's the same thing. And then when we go to the hypotenuse, we multiply by the square root of 2. So 2 roots of 2 is 2 roots of 4, which is 2 times 2, which is 4. All right. The next one, when we've got the hypotenuse given, so to go backwards to these two, we have to divide by the square root of 2. So it's 2 roots of 6 divided by the square root of 2. Now, this is nice. We can just algebra practice here, right? We can do that, which just becomes 2 roots of 3. So a lot of Algebra 1 skills coming back to play. And let's do a couple more examples here, my friends. And then again, we're going to do this so much in class. So we're going to keep practicing these bad boys until you get the hang of it. All right, so here's a 60 side given. Given the 60 side, this one's kind of a pain, but look, this was nice. This example already has root 3 in it. So when I go backwards to the 30 side, I have to divide by the square root of 3, and look how nice that is. SATs will do that a lot just to clean things up for you. So then once you have the small side being 5, I know that the hypotenuse is double that, so that has to be 10. All right, and here, given the hypotenuse, the side opposite 30, cut it in half to 4, and then I can go to the side opposite 60 by just multiplying by the square root of 3. All right, so again, this might seem like a lot right now, but the more you do it, you're going to get the hang of it real fast. and we're going to use it the whole rest of the year, so it's going to be awesome. All right, so our lesson check, knock these out for class, and I will see you next time. Thanks again, Miss Winnick. Peace.